Hello, Math 1. This lesson's on 3.b, which is I can graph the solution to a linear inequality. Now, if you remember from the last chapter, right, we talked about what an inequality is. And it's a mathematical sentence formed by relating two expressions using, right, either the less than symbol, the greater than symbol, less than or equal to, or greater than or equal to symbol. Now, it's important to know how to read these and understand that as math teachers, we prefer the variable to be on the left. So when we read it from left to right, such as we say in this case, x is less than a. Okay? So remember, the alligator always eats the bigger number. So if a is bigger than x, we know x is less than it. The next one would be read as x is greater than b. Okay, the next one would be x is less than or equal to c. And finally, the last inequality would be x is, in this case, greater than or equal to d. Now, like an equation, we can solve inequalities, and we talk about what the solution to an inequality is. And the solution to an inequality is, or are, the values of the variable that make the inequality true. Okay, and that's important to know, right? That an equation generally has one solution. And when we talk equations, we're talking linear, the ones you know right now. Now, when we do graph these solutions, because there's more than one, and there technically ends up being an infinite number. Because if you take something like, let's say, x is less than 5, we can come up with an infinite number of values that would make that true. 4 is less than 5. 3 is less than 5. 0 is less than 5. Negative 1,000 is less than 5. We can come up with an infinite number of values that when we plug it in, it would make that inequality true. And because of that, when we graph the solutions, we generally graph and then shade in the values that make the inequality true. So now, when we go to check to determine if a value is a solution to an inequality or not, instead of, say we don't know how to solve the inequality, how can we check to determine if it's a solution? Well, all we do is we plug the number in and determine if it makes a true or a false statement. So when I look at the first one, I can take this value of x and plug it into that inequality. 3 times 4 plus 4 is less than or equal to 7. If I evaluate that, 12 plus 4 gives me 16. Is 16 less than or equal to 7? No. Therefore, that's not a solution. If I look at 1, 3 times 1 plus 4, is that going to be less than or equal to 7? Well, 3 plus 4 is 7. 7 is less than or equal to 7 because this little line here tells me they're equal. X is equal to 2. If I plug that in, 3 times 2 plus 4, it's going to give you 6 plus 4, which is 10. Is 10 less than or equal to 7? No. And let's look at negative 1. If I do 3 times negative 1 plus 4, is that going to be less than or equal to 7? Well, negative 3 plus 4 would give me 1. 1, is that less than or equal to 7? Yes. Therefore, these two values are solutions to the inequality. So example 2, I could do the same thing. Plug in the value of x and then determine if it's true or false. So if I look at the first one, 4 times 2 times 10 plus 5. If I evaluate that, that's 20 plus 5. So it gives me 4 times 25, which is 100. Is 100 less than negative 44? No. Therefore, that's not a solution. If I look at the next one, 4 times 2 times negative 8 plus 5. That will give me 4 times negative 16 plus 5 will give me negative 11. 4 times negative 11 would be negative 44. Is that less than negative 44? Negative 44 is not less than negative 44. It's equal to, and since this does not have that little line under, that is not a solution. Now, the next one, plug it in, is 4 times 2 times negative 9 plus 5. So that there would give me 4 times negative 18 plus 5 would give me negative 13. Is negative 52 less than negative 44? And the answer is yes, it is. And then the last one is 4 times 2 times negative 10 plus 5, right? That's going to give me 4 times, that's negative 20 plus 5, which is negative 15. Is negative 60 less than negative 44? Yes. Now, whenever we graph an inequality, right, there's two things we got to do. One, we got to plot a dot, and two is we got to shade. So here's the thing. If you are using the less than symbol or greater than symbol, meaning you're not equal to, you would use what we call an open dot on the number line. So you would plot an open dot. And that means it's not part of the solution. If we use less than or equal to or greater than or equal to, we use a closed dot, like such. And that tells us that the number is part of the solution. All right. Now, if I put this, x is less than some number, or x is less than or equal to some number, right? This is read less than. So when we see less than, we know we are going to shade left, because numbers less than will always be to the left. If I use greater than a number, or x is greater than or equal to a number, that means all the values of x that are greater or bigger than a number, that's going to tell us we're going to shade to the right. Okay, so let's take a look at some of the graphs. So the first one, x is greater than 6. So when we look at it, that's x is greater than 6, right? So we know we're going to go to 6 on the number line. And because we're not equal to, right? Not equal to means we put a open circle there. And all the numbers greater than 6, right? If I had to plug numbers in here that make that true, I would have to say numbers like 9, right? 10, 12, 50, which means I'm going to shade to the right. And I put an arrow on the end here because it extends forever and ever to what we call infinity. So the next one, right? This is red. X is less than or equal to 0. Because we're equal, that little line tells us we're equal. That tells us we have to put a closed dot on 0. And all the numbers that are less than or equal to 0 are all going to be to the left of 0. So we shade to the left. Okay. Next one. This is red. X is less than negative 4. We're not equal to, so right away, this inequality symbol clues me in on an open circle. So we go to negative 4, plot an open circle. And since we're less than -4, where are all the numbers less than -4? They are to the left of -4. Okay. Now, the next one. I highly recommend we always read from the variable to the number, or we rewrite these problems with the variable on the left. I write x on the left, 5 on the right. If I look, this little alligator's eating x right now, so I have to keep it eating x. So now when I go to graph that, I read this as x is greater than or equal to 5. So I know it's going to be a closed dot because I'm equal to. That symbol tells me equals to. So closed dot on 5. And right away I know greater than or equal to means we're going to shade to the right. And that would be the solution graphically. Number 7, x is less than -3. We want to rewrite this one. X on the left, -3 on the right. The alligator is eating -3, so we keep it eating -3. And now we read this as x is less than -3. Because we're not equal to, we know we have an open dot on -3. And less than means we shade to the left. Okay, so I'm going to break this up into a 2-part lesson. The first part being graphing, the second part being interval notation. So do me a favor, pause the video, end the video, go and work on the student practice worksheet that involves graphing, and let me know if you have questions.